Okay, well, welcome to this exercise. We are going to look at the correction on business statistics and social research method. We'll continue from yesterday class. Okay, so it's very important we take note of the corrections and the logics and the strategy of learning or preparing for this exam, the way the questions are being framed, the area of concentration, the logic in the questions with reference to not, except. These are negation that will make you think in an anti-clock direction. So our thought pattern, the way our thought pattern is being framed is very important. So hence this revision, this practice to make us be more abreast with the way the questions appears, and hence reinforces our knowledge in the course of our training and studies. So welcome everyone. So let's take little question from the chat. If there are questions regarding what we have discussed or yesterday's discussion, it is still the same course we are still looking through, evaluating, and try to master. If there are questions you feel we should ask, you can just drop on the chat so that we can answer. If there any feedback that you need to give us, you can share it now so that we can put that into consideration in our discussion. So let's see from the chat if there are questions being asked so I can attend to them before we begin. Okay. Just a moment to look at the chat box and respond to the questions there. Okay, we look at sample rotation sampling. Let's look at these terms and also look at how they appear on the questions and what makes it the correct option. So understanding this will give us insight. Okay. Sample rotation sampling is a sampling method in which every member of the population has an equal chance of being selected. Recall in class we elucidated this very well. Here is surfacing again. So we also, I encourage you to go back to our audio, the recorded lesson, and play back again as you prepare for this revision. It would be nice you play back those audio again. I know that time is of great essence, a lot of things, work and family, but in playing them, it will reinforce your understanding, and where in class you can be able to relate, can be able to remember. So we expect you to do that even as we continue on this revision class. So these are ways that it will reinforce your understanding. It's a way that it will make this sink into you. It's a way that you can easily remember what was taught And when under exam situation, you happen to see any of these questions, you'll be able to approach it and make sure you take the right option. So a sampling rotation sample, simple rotation sample, sorry, is simple rotation sampling is a sampling method in which every member of the population has an equal chance of being selected. Okay. All right, we proceed. Welcome everybody. So we look at the first question we have here. It says, what is the researcher, when the researcher makes a random selection according to equal chances from a population, it is known as dash sampling. Stratified, cluster, quota, no, it is a simple sampling, simple random sampling. Recall we discussed it in our lecture. Like I said before, it's good we play back those our audio. It will reinforce our reading and also this revision. So the answer is B. Simple random sample is the answer. Because recall that we did mention that simple random sampling is a sampling method in which every member of the population has an equal chance of being selected. And why is it the answer? Why is it correct? The phrase equal chance is the likely cue. So equal chance. So we are looking at this question and trying to give you background knowledge to really internalize and understand them. You know, in simple random sampling, selection is completely unbiased. Why? Because every unit has the same probability of being chosen. You know, for example, drawing names from a hat where every person has one slip of paper. You know, so in simple random sampling, is simply saying there is a method that every member of the population has equal chance of being selected. Hence is the answer for question 1, saying that when the researcher makes a random selection according to equal chances from a population. So quickly, what comes to mind is the simple random sampling method or technique. 2, the hypothesis to be accepted when a computed value is greater than tabulated value is known as dash hypothesis. Of course, it's alternative, it's not null, it's not simple, it's a alternative hypothesis. How? In hypothesis testing, when the calculated test statistics have exceeded the critical, that is the tabulated value, the null hypothesis is thus rejected and the alternative hypothesis is accepted. So the hypothesis to be accepted when a computed value is greater than tabulated value is known as alternative hypothesis. So further explanation is shown here. We are saying that in hypothesis testing, when the calculated test statistics exceed the critical or tabulated value, then the null hypothesis is rejected. What happened is that the alternative hypothesis is accepted. But why is it so? Why is the answer correct? Simply because the alternative hypothesis represents the claim that a significant difference or relationship exists. That is why it is so. Okay, next question again. We are saying here, question 3, a distribution that has equal value of mean and variance is known as what? We have said it before, is known as Poisson. Poisson. It's not binomial, it's not simple, and it's not normal. It's Poisson. Okay. So the other common distribution process, this exact characteristics. So this is how it is being explained. A major property of the Poisson distribution is mean is equals to variance. So we'll have this in mind that when the mean is and the variance has equal value, it is Poisson. So that is the concept we will have in mind. Then looking at a cyclical variation, I start from defining what it means. Let me explain before I go to the answer. Cyclical variation do refer to long-term upward and downward movement. Upward and downward movement. That is a long-term upward downward movement around trend line, usually associated with business cycle. So that's what we call cyclical variation. Why is it so? The phrase rising and falling over time indicates fluctuation, cyclical fluctuation. So recall this rising and falling so that you can be able to remember. So let's go to the question. The question says a systematic rising and falling of time series date is called dash variation. Systematic rising and falling. So these are key terms. They are just like a nomenclature. We should understand them, know them. So as soon as we see them, we know what it is. They are the vocabulary of the business. There's no other way to know them. Is to understand them that way, know their name, and when I say cram them, you must know them. When you hear a systematic rising and falling over time, series date is called cyclical variation. And what it is, it's not secular, it's not irregular. Mistake may be made when you see rising and falling, you go to say irregular variation. No, it's not irregular. So the term there is a cyclical variation or seasonal. When you hear rising and falling, okay, rise and fall is seasonal. So this is just to confuse you. But with this illustration, you're no longer confused. Remember, a systematic rising and falling of time series date is called cyclical variation. Okay, so a fair die tossed. A fair die is tossed. What is the probability of getting equal number? What is the probability of getting equal number? The probability of getting equal number is the equation assume two dice are tossed. Yes, this is used to play Ludo now. So the probability of getting equal number is 6/36. C is the answer. I don't know how this can come under question, how to illustrate this for your understanding, but it goes this way. The possible outcome is, it is 6 times 6. Will give you this number times 6 and equals to this times 6 into 2 places. So that's the way you multiply it. So equal number occur as 1, 1, there's 1, there's 2, 2, there's 3, 3. These are how it is. I mean, when I talk about that, the thing we use in play, we call it Ludo game. That used to be white, and it's only 2 inside. So that's what we call dice. So you used to have 1 dot, 2 dot, 3 dot, 4 dot, 5 dot, and 6 dot. That's how it is being designed. And it is 2 inside. So you have to calculate all of this number into 2 places. So that is the way it goes. That's where we land at C. So here, looking at the mean, we remember that mean is adding up and dividing. Calculate the mean of the following set of number. What we do here is that we add 5, 3, 10, 2, divide by number 4. They are into 4 places. The data set is 4. 1, 2, 3, 4. That is 5, 3, 10, and 2 is 4. So you add it up, gives you 20. This is 10, this is 15, this is 3 and 2, 20. 20 divided by 4 gives you 5. That is the answer. So the arithmetic mean we already know is obtained by dividing the total value by the number of observation. That's how that one is being done. We are familiar with it. So that is how it's done. Let's proceed. So the following are measures of the dispersion, except median. Dispersion is range, quartile, and decile. We discussed that already before. So measure of dispersion describe the speed of data. Example is range are here, variation, standard deviation, and quartile deviation. So median is a measure of central tendency, not a dispersion. It's a measure of central tendency. It's not a dispersion. Okay. So let's look at this. The test used for the equality of two population proportions for large samples is depicted by dash test. We're looking at the test that is being used for equality of two population proportion when considering a large sample is often depicted by which test? It's often depicted by Z-test. So when you hear the Z-test is commonly used to compare two population proportion when sample size are large. So don't forget this, the Z-test is commonly used to compare two population proportions when sample sizes are large. And why is it? Large sample theory assume normal approximation, making the Z-test quite appropriate. So that being said, we are saying that the Z-test is commonly used to compare two population proportion. See how the question is being framed. It said the test used for the equality of two population proportion for large sample is depicted by dash test, is by Z-test. Don't forget that. Okay. We look at find the mean of the distribution. Find the mean of the distribution. The mean here is 4.01. How do we explain this here in this platform? Let's see how I can navigate to do that. See how I can navigate to do that. Okay. That is question what? Question 9. So hold on, let me try to offer better explanation to that question 9. I tried to read it earlier on. Okay. So the question 9, so what do we do? What do we do? We are looking for the mean of the distribution where we have X, we have 2, we have 4, we have 7, and for F we have 4, we have 5, we have 3. So how do we solve that? Under X, what we'll do is 2 times 4 plus 4 times 5 plus 7 times 3. So under X, we have 2, and under F, we have 4. We'll say 2 of X times 4. Okay, we have to keep it there. We add 4 times 5, we have 7 times 3. So you use the figures that are in X to multiply the figures that are in F, just as is shown on the slide. Here, we use this times this F, this X and F. The X-axis, let's say there's a line you draw like this. Let me see if I can do it here. Let me see if I can do it from my end here. It's not going. So under X is 2, 4, 7, while F is 4, 5, 3. So 2 here will times this, 4 up will times 5, 7 will times 3. So when you say 2 times this plus 4 times 5 plus 7 times 3, that is the way to go about it. So at the end of the day, you now have 8 plus 20 plus 21 equals to 23, equals to 49 rather. So you do summation F is equals to 4 plus 5 plus 3 equals to 12. So to get the answer is 47 over 12. It will give you 4.08. To explain it, we are saying the weighted mean consider both value and their frequency. Frequency is the F, the value is the X. So like I said before, I'll say 2 times 4 plus 4 times 5 plus 7 times 3. And that will give you the addition there is 8 plus 20 plus 21 equals to 49. Then the 4 plus 5 plus 3 is 12. 49 over 12 will give you 4.08. And that is the answer. A is the answer. To explain this will be quite difficult for you. I thought to put it in this form, but let's proceed. So here, the annual turnover and frequency, okay? So the cumulative frequency corresponding to this and this, the answer is, how do we get this? Okay, so yeah, I think I worked this earlier on. So this is the turnover, this is the frequency. We now put the class this way, 1 to 5, frequency is 3, cumulative frequency is 3. 6 to 10, 5, cumulative is this. So the summation is, look at what you're adding up here. This is the frequency, okay? So 3 plus 5 plus 2 equals to, I'm getting the cumulative frequency obtained by adding frequency from the first class to the class of the interest. Let me try to ask you a question. So which question are you referring to? Which question are you referring to? 4.1. Sorry. So let's proceed. Until you answer me, you can go back there again. So 11 says, which of the following sampling method is non-random? This is a walkover because we discussed this extensively. Which of the following sampling method is non-random? It is quota. Quota sampling is a non-probability sampling technique where respondents are selected based on predetermined quotas rather than random selection. So why it is quota, why it's correct is simply because the researcher deliberately chooses participants until the required quota is filled. meaning not every member population has equal chance of selection. That's correct. So selecting 20 male and 20 female from population without randomization, that is the quota we are talking about. So the answer to our question here that asks us which of the following sampling method is non-random. The answer is quota. Quota sampling is a non-probability sampling technique where respondents are selected based on predetermined quota rather than random selection. Okay, so let's move on. Let's move on. So which of the level of precision and reliability of data set is determined by what? Level of precision and reliability is by coefficient of variation. It's not skewness, it's not kurtosis, it's not mean deviation, it is coefficient of variation. How? You know, the coefficient of variation CV measures variability relative to the mean. That's what it does. A lower coefficient of variation indicates greater consistency and reliability. All right. So next question present to us saying the difference between sample statistic and population parameter due to chance is determined by test of significance. It's not level of significance. Take note of that. It's the test of significance, and a test of significance helps determine whether the observed difference between a sample statistics and a population parameter is due to chance or reflect a real difference. Why this is a correct answer is because hypothesis testing is specifically designed, essentially designed to evaluate whether observed differences are statistically significant. So back to test of significance, we say it helps determine whether the observed difference between a simple statistic and population parameter is due to chance. We want to know this difference and how is it due to chance or really did it reflect the real difference? So that is test of significance. That the reflection or the difference I'm seeing here, what I'm observing, is it as per chance, is it an error, or is it the real difference? That's what we are looking here. So the next question says the difference between third and fourth percentile is called interpercentile. It's not semi-quartile, it's not interquartile, it's not percentile, but interpercentile. Why? You know, the difference between, you just have to know this term, understand them. There's no other way to explain it. Is a nomenclature in the subject matter. Is a language. You have to get it. You know, the difference between the third and the fourth percentile is a interpercentile. And by way of explanation, we are saying that the difference between two percentile is known as interpercentile range. Okay. So the process of selecting fractional parts of a population is known as sampling. Fractional part is known as sampling. The process of selecting fractional parts is known as sampling. Okay, let's not forget that. And why is this so? Sampling involves selecting a subset from a larger population for study. You know, researchers often cannot study the entire population. That is why a representative sample is selected. That's how we come about sampling. Okay. So the two aspects studied in statistics of human population are Dutch and social statistics. Is a walkover is demography, and social statistics is the two aspect that is studied in statistics of human population. Recall the question say human population, demography and social statistics is what is studied. So demography is the systematical study of human population. You know, birth rate, death rate, migration, population growth and population distribution. Population statistics are broadly divided into demography and social statistics. Let's get that. Population statistics are broadly divided into demography and social statistics. While demography do provide us quantitative information about population characteristics. That's what it does for us. Okay, the next question talks about a situation of compromise index between current weighted and base weighted index is called what? Compromise index, between current weighted and base weighted index is called Fisher ID index. It's Fisher's. Fisher ID index does combine the advantages of both, combine the advantage of both. Okay, binomial distribution can be approximated to a Poisson distribution when the sample size is what? Is too large and probability is too small. We met Poisson distribution earlier on. So binomial is when it is too large and the probability is too small. Okay, so let's get that. Okay, this one we discussed in class. The degree of symmetry in a distribution is known as skewness. The degree of symmetry in a distribution is known as skewness. So skewness measures the degree and direction of symmetry in a distribution where we have positive skewness, negative skewness, and zero skewness, symmetrical. So a perfectly symmetrical distribution has zero skewness. So let's try to remember this. We laughed about it in class. Skewness and kurtosis. So the process of checking questionnaire before tabulation is editing. This is English, no need. It's English. The totality of elements in a statistical study is called targeted population. Totality of elements in a statistical study is called targeted population. A population we know refers to the entire collection of elements, individual or observation that are relevant to the study. That's what it is. So index number is a dash tool which measure difference in price and commodity. Index number is a statistical tools, Index number is a statistical tools which measure differences in prices and commodities. An index number is a statistical measure used to show changes in a variable or in a group of related variable over time. So let's remember what it is. Index number is a statistical measure that is used to show changes in a variable or a group of related variables over time. And the question here says index number is a dash tool, is a statistical tools which measure difference in prices and commodity. Okay, the numerical width of any class in a particular distribution is called class what? Class interval. Class interval. Class interval is the difference between the upper and the lower limit of a class. We discussed that in our class, in our discussion. 29 to 20 to 29, So there's a class interval here. The class interval is 29.5 to 19.5 is a class interval, or rather 19.5 first to 28.5 before you meet 29 is a class interval. So class interval represents the width of a class in a frequency distribution. So looking at the method that is being employed to construct a frequency table, especially when there are many observations, is known as a tally representation. We use it to do what? To construct a frequency table. It's known as tally. A tally system uses mark to record occurrences before summarizing them into frequencies. You know, so we know what tally means. We don't need to start drawing it. Any quantity of statistical population, any quantity of statistical population that summarizes an aspect of that population is called parameter. You know, it's called parameter. Any quantity of statistical population that summarizes an aspect of the population is called parameter. A parameter is a numerical measure describing a population, population mean, population variance, population proportion. So that is what parameter does. Parameter describe population, whereas statistics describe sample. Try to remember this. Parameter describe populations, whereas statistics describe samples. Let's not forget. Okay, class boundary. We taught about this in class. The difference between upper class limit of one class and lower class limit of the next class is called class boundary. So about interval and class boundary, even class size. So class boundary is the difference between the upper class limit of one class and the lower class limit of the next is called a class boundary. You know, the class boundary separate adjacent classes and eliminate gap. You know, so that is it. Looking at the class here, we say 9 to 19 is a class, 20 to 29 is a class. But before you get to this 20, there should be 19.5. There should be that 19.5. So class boundary ensures continuity in a group data. So the next observation here is that an estimation which involves the use of specific value obtained from a sample is known as point estimation. Point estimation is the estimation which involves the use of specific value obtained from a sample is known as point estimation. Point estimate uses single numerical value to estimate population parameter. A graph cumulative frequency against upper class boundary is called cumulative frequency. No, it's a graph cumulative frequency against upper boundary is called ogive or curve. Yeah, curve or ogive is a curve. It's called curve. So that is where we are. That is where we are. Let me go back to that 9. Let's see what we have at 9. No, that 9 is 4.8. We'll have 4.8, we'll have 4.6. In fact, when you divide 49 over 12, will give you 4.01. You didn't approximate, yes, we didn't approximate 4.06 and 4.09. So here, look at it. This is what we'll have. Eventually, it's 49 over 12. Okay, I can write here. When you have 49 over 12, it gives you 4.08 exactly. So we didn't approximate it to 4.1, no, because we have by the nearest could be this. Assuming that there is no, this is the exact division, 4.08. So there's no approximation. And if you watch all of them, they are in decimal point, 4.06, 4.08, 4.07. So there's no approximation here. So we'll go for the exact answer, which is 4.08. That's what happened there. Okay. So I drop a question on the chat. Can I get that from you? Or let's run to the end. We have discussed this before. The probability of arrival time in queuing theory follows dash distribution, is Partial distribution. So we have discussed this before. This is another angle to it again, that the probability of distribution of arrival time in queuing theory, it follows which distribution also is Poisson distribution. In queuing theory, arrival usually follows the Poisson distribution. Service time usually follow exponential distribution. So the Poisson distribution method models the number arrival occurring within a specified period. I think that is all. And these say the following are disadvantage of secondary data except. It didn't ask question with except, they are not complete yet. Except is time consuming. Yes, it's time consuming. That is the negation there. Secondary data generally easily accessible, is less expensive, fast to obtain. So the exception here is time consuming, except. So that is what we have on that. We'll continue to review them. You're gonna listen to it again, look at all our earlier class discussion, play the video and listen, bring forth specific questions so that we can treat maybe outside this platform, we can treat those questions. I didn't discuss more of calculation question here because it can be confusing because you are not engaging the way the platform is. It didn't give you much room for engagement. It's almost a one-sided direction. So questions can be picked up and we find time to treat them. So that means you have to read extensively to have your questions. You have to read extensively. When there's poor understanding, we can refer to the manual. I can go there and read along so I can do sharing also. So as much as time permit, reach out for personal questions you may encounter in the course of your studies. So this platform cannot give us the best or all of it, but it will support our understanding and our preparation. Thank you for the time shared. Thank you very much. We have come to the end. So see you tomorrow, same time. If you have questions, you can let me know during the day. Personal or group questions, will attend to them. That means you have to be really ahead to really have questions to ask. Time is not our friend. Thank you very much. Bye.